Hey guys, hello. Hi everyone, am I audible? Am I visible? If you can see me, if you can hear me, you know the drill. Just let me know. Guys, are you there? Hello everyone. I'm still not able to see myself here. Okay, I think now I can see myself. Hi guys, how are you all? Now I can see all of you here on the chat box as well. I can see Pranati, Vinod, Ashutosh, full masti, full maza. Very nice. Namaste, namaste, namaste. सिद्धार्थ is here, संगीता is here. क्या हो गया यार? बहुत कम लोग मुझे लाइव दिखाई दे रहे हैं. How are you guys? Yes, Siddharth, I can see you. Hello. Okay, Pranati, तुम लावण्या हो. Why would you change your name by the way? Okay. Hi, Shashikala. Shashikala is Mitlesh. Very nice. People are not using their name. Maybe they are using the IDs of their elders. Hmm? How are you guys? I welcome you all again, by the way, to Vedantu's JEE channel. And this is specifically a series which is going on for students who moved from 10th standard to 11th standard. That means हम सब 11th standard में जा रहे हैं. Yeah? I miss you all guys too, yaar. Very nice, very nice. Namaste, namaste everyone. Namaste once again. I hope even after the lockdown is going to get completed, you guys will stay safe. You guys will try to maintain the social distancing from the others. Okay. So, guys, today's session is non-uniformly accelerated motion. Okay. I'll get back to the academic part also, but I know that there are always students who are new on the channel. Okay. So, guys, let me start with my introduction. This is me, your Suri Sir. Okay. And I am also known as Mugambo on this channel. Why? Is because when you will crack this examination of JEE, Mugambo khush hoga. Yes, yes, yes. So guys, if you are new on the channel, if you have been here for the first time, then obviously you would want to know what exactly is the schedule which we are following for JEE 2022. Yes, this is the year when you guys will be appearing for JEE. So let me tell you who are the teachers. Yes, this is Love Sir. He is your chemistry guru. This is Arvind Sir. Okay, guys. Arvind Sir is your mathematics teacher. Okay, he'll be teaching you maths. And this poor person is me, and I'll try to teach you all physics. More importantly, what is the time when you will find us here on the channel every day? As you can check the clock right now, it's 7 p.m. and at 7 p.m. every day we study theory, and on 3 days of the week we do MCQs. Okay, and I promise you guys we'll be doing Menti in physics as well. Okay, so guys, on Monday and Friday I meet you. On Wednesday and Saturday Love Sir से आप लोग मिलते हैं. Apart from that, on Tuesdays and Thursday you meet Arvind Sir. But importantly, on Tuesday, Saturday and Friday we do MCQs. Okay, so what is to be kept in mind? Every day 7 o'clock be on the session, be on the channel. Okay, good, very nice. So guys, one more important thing for people who are preparing for JEE 2022, you know that during the lockdown still your classes are not on, your schools have not opened yet, but your preparation is continuing with the help of Vedantu, I'm sure. And if you want, you can come on Vedantu's platform and join a batch which is targeting JEE 2022. How can you join? You can see that there is this link which is mentioned here. You have to just go in the description box. Okay, you will find this particular link in the description box. Okay, and in the description box, guys, all you have to do is click on that link and go and enroll. Okay, so it's free of cost enrollment. You don't have to pay any fees for joining. Okay, cool. So take the advantage. Very nice. Cool. And if you are new to the channel, definitely let me ask you to subscribe to the channel as well. Why not just subscribe, by the way, I want you people to press the bell icon as well, so that whenever I'm coming live, whenever any video is coming from my end, from Arvind sir, from Love sir, you don't want to miss out on anything that we guys are putting here on the channel for you guys. Okay, so how can you stay updated is by clicking on the bell icon along with the subscription. Cool, awesome. So guys, let's go forward, आगे जाते हैं और start करते हैं आज का session. And today's session, as you can see, is about non-uniformly accelerated motion. So guys, so far what has happened in the story of motion, we have talked about uniform motion. Yeah, this is when your body's velocity is constant. We spoke about it in last to last lecture. Okay, then there is non-uniform motion. Okay, so when the motion is non-uniform, what happens then, guys? Yes, the velocity of the body is not constant. That's how simple it is. But then when it is not constant, that simply means it is changing. And when it changes, we can also call the motion to be accelerated motion. So for an accelerated motion, there are two types again. One is uniformly accelerated motion, which we completed in the last time. This is basically when your acceleration of the body is constant. Okay, and then the part that we are going to talk about today is non-uniformly accelerated motion, which now you can relate. Acceleration itself is also not going to be constant. That means nothing is going to be constant here. Whenever anything is moving, neither its velocity nor its acceleration is going to be constant. Now, the more important part here that I want you people to actually feel, yes, a lot of important correlations can be understood by just visualizing things in physics. You know that, okay? Physics is all about having a good visualization. So, I will rather put this motion as the most realistic motion. This is the most realistic possibility of motion. Why am I saying that? Well, I'm saying that, guys, because if you will think of the very first type, which is basically your uniform motion, look around yourself, try to think about it. Do you know any object around you which is performing uniform motion? Just give it a thought. I don't see any object around us which is moving with a constant speed, constant velocity, and going along a straight line. No, neither a car, nor a train, nor an aeroplane, nor a bicycle, nor a truck, or not even an individual or insect. Nobody actually is moving with a constant velocity. So uniform motion is the most idealistic motion possible around us. Does not happen. Okay. When you talk about non-uniform motion, and in that you speak about uniformly accelerated motion, that means if we speak about this category, then in this category, guys, yeah, so in this case, there is only one practical possibility for a uniformly accelerated motion. Assume or think about it, a car accelerating and continuously accelerating. Doesn't happen. If you will sit inside a car and it will keep on accelerating the speed, there will come a time when the speed will not be increased because of maybe any force, maybe a vehicle coming in front, so many signals outside. So only practical case of uniformly accelerated motion was motion under gravity, when anything is dropped or anything is thrown vertically upward, when acceleration is g, 9.8 meter per second square. So why do I call this particular motion as the most realistic motion? Is because that is how things move around us. Any car, any object, any person, any insect, any aeroplane, anything which moves around us performs non-uniformly accelerated motion. That's how simple it is. Okay, and as I'm talking about, see, I can read some comments also. People are saying, what about the uniform circular motion? So guys, let me again put you back to the understanding that right now we are speaking about 1D motion. 1D motion means objects which are moving along a straight line. We will come back to two-dimensional motion, and there we will speak about circular motion as well. So do not worry, we will get back to that part. Okay, perfect. Okay, thank you, Sanjay. Thank you for the appreciation. Okay, guys. So such is the motion very realistic motion. And in 8th standard you studied uniform motion, in 9th standard you studied uniformly accelerated motion, in 11th standard now you're going to study very much in detail non-uniformly accelerated motion. So one question comes in my mind: why till 9th standard, or till now till 10th standard, for 10 years I have been studying, why I was not introduced to a realistic motion yet? Why I was not studying something which is realistic? Why I was studying something which is actually ideal, does not happen practically? Reason is, to study uniformly accelerated, non-uniformly accelerated motion, the topic for the day, you need the technique of calculus. You need to know the technique of calculus to solve and to study the non-uniformly accelerated motion. Understood, guys? I hope the thing is clear to all of you now. So when we are talking about non-uniformly accelerated motion, so let's try to understand. Very little theory are there for this particular motion. I'm going to actually spend 90% of today's session only on problem solving, okay, with you guys. So guys, when we were talking about uniform motion, I told you that there was no acceleration, body's velocity was constant, so obviously no acceleration. We spoke about uniformly accelerated motion, so acceleration became constant. And now when we are speaking about non-uniformly accelerated motion, even the acceleration is not constant. ये तो सबको clear हो चुका है. Thing that I want you people to look here is that when I speak for 4 seconds time interval, say if a body is moving with uniform motion, first case, then the velocity you can see is constant. So if velocity is constant, then definitely your acceleration is 0. There is no change in the velocity, as simple as that. But when we were speaking about uniformly accelerated motion, case number 2, so in, say, for an acceleration value 1 meter per second square, you can see that 1, 2, 3, 4 seconds, the body's velocity goes from 1 to 2, 2 to 3, 3 to 4, which means the change of velocity in every second is constant. That is 1 meter per second square. Okay, getting it, guys? I hope you were there in my previous class, because this is what we in detail study. Now look at this, guys. When you don't know what is the value of acceleration from 1 to 2 to 3 to 4 seconds, look at the variation in the velocity, guys. Velocity was 1, in the next second it became 3 meter per second, then it became 6 meters per second, it became 7 meter per second. If you try to calculate the value of acceleration, how do you calculate the value of acceleration, by the way? V2 minus V1 upon T2 minus T1. So this is your V2, this is your V1, that value is 2. And what is the time change here? It is 1 second. So 2 by 1, that gives you the acceleration 2 meter per second square. Similarly, here it is 3 meter per second square. Here it is 1 meter per second square. Okay? Are you guys getting this part now? Are you getting what exactly is non-uniformly accelerated motion? Random change in the velocity. Random change in velocity. So how will I define non-uniformly accelerated motion? A motion in which when a body is moving, its velocity is changing randomly with equal intervals of time. Okay? Okay? Okay. It's okay. Hitesh does not know my name. That's okay, Hitesh. Hitesh, my name is Suri Sir. Okay? You can watch the video again. Later on, you will get my introduction again. Cool. So guys, the best part about this particular motion is that there are no equations of motion. You don't have to memorize anything here. You don't have to memorize anything. Everything that you need to know is already done in this chapter. So see, when you talked about accelerated motion when it was constant, these were the 3 equations of motion that we studied in our previous class. V equal to u plus at, s is equal to ut plus half ad square, and v square equal to u square plus 2as. Look on the right side box. Look here, guys. This is non-uniformly accelerated motion. And here, what you need to know is that velocity is differentiation of displacement. Acceleration is differentiation of velocity. And by the way, guys, when we say acceleration is dv by dt, okay, this equation, just let me tell you how the third equation comes. What I'm going to do here, guys, see this. I'm just writing this in the form of chain rule. If you guys remember in calculus, we did something called as chain rule. So what I'm doing here, this is dv divided by dt. I'm writing ds in numerator and denominator here. So what I have written is nothing but chain rule. This is dv by dt only. So, but dv by dx into ds by dt, this is the change that we have done. Now, what exactly is ds by dt? Have a look at this. ds by dt is nothing but v. So, this becomes v into dv by ds. Okay, guys, getting this part? Okay. So, these are the three equations that we will be using. So, acceleration is going to be dv by dt and v dv by ds as well. Both the equations will be used. Okay. So, guys, before I move to the problems from here, because no theory at all to be done, all I want to tell you is that if you have displacement as a function of time, then from here you will find velocity as ds by dt, and you will find acceleration as double differentiation of displacement. If you have displacement as a function of time, this is velocity and this is acceleration. Okay. Similarly, if you will have velocity as a function of time, then what will happen? If you will find acceleration, you will have to do differentiation of the velocity. I will tell you in the form of examples also, don't worry. And if you want to find out displacement, you will have to integrate the velocity. This is everything that I taught you people in the previous session also. Okay. This is just a quick recap of what we have studied previously. And if you have acceleration as a function of time, or you can say acceleration's graph with respect to time, then from here you will just integrate it once to find out the value of change in velocity. You will get this ADT. But if you have velocity as a function of displacement, then you will find out acceleration as v dv by ds. So from here you will find out dv by ds and you will multiply it by v to get the value of acceleration. Okay. Yes, Yuva, IIT Roorkee versus IIT Bombay video will be uploaded by tomorrow morning or day after for sure. We have recorded it. Due to some technical issues, we could not go live for that session, but we did the recording. And IIT Roorkee and IIT Bombay, the competition that we were going for yesterday, we have recorded it, me and Arvind sir, both of us. So that session is gonna go, it will be premiered maybe I think by tomorrow morning or day after for sure. Okay, so stay tuned. Thank you, Ravindra. Thank you so much. So guys, let's head to the questions now. I'm jumping to the very first question. So guys, a lot of questions are going to be there and I want you people to stay with me, try to answer in the chat box. More importantly, try to understand, because a lot of calculus will be used here. Okay. So guys, very first question. The displacement of a body is given to be proportional to the cube of the time elapsed. What does the question say? That S is proportional to T cube. This is what has been given. Displacement is proportional to T cube. So the magnitude of acceleration of the body is going to be how it is going to change with time. So if I go by velocity, which is basically ds by dt, you can see that if displacement is kt cube from here, then the differentiation of it will give me the velocity. Velocity is basically the differentiation of displacement. So what does it give me? It gives me 3kt square. Okay. But what question is asking me is about the acceleration. Okay. So guys, acceleration is going to be dv by dt. So I'm going to differentiate this part. For that, I will have 3k into 2t, or you can say it is 6kt. And what you see, that acceleration is basically proportional to t. What does it mean, guys? It means that acceleration is not constant. And as time value will increase, your acceleration value will also increase. You can just start putting the value of t as 1 second, 2 second, 3 second. You will see that the acceleration value will also keep on increasing as 6k, 12k, means acceleration will come out to be 6k, 12k, 18k. That simply means if time is increasing, acceleration is also increasing with time. Very nice, guys. Very nice. Keep it up. Keep it up, guys. Next one. So this one says that the velocity of a body depends on the time according to the equation. This one. So the body is undergoing what type of acceleration motion? So again, velocity is given to us as 25 plus 0.6 t square. So if I want acceleration, obviously I'll have to differentiate. So differentiation of 25 is 0 because it's a constant, and differentiation of t square will give me 2t multiplies with 0.6. So 0.6 multiplied with 2t is what you are getting, which is basically 1.2t. So what you see here, that acceleration is again proportional to time, which simply means that it is not a constant. So acceleration is not constant. So definitely answer is not A, it is not even B, it is not even 0. So answer is again non-uniformly accelerated motion, which means the acceleration of the body is going to increase as the time is increasing. Okay. Okay guys, next one. This says the displacement time equation of a particle moving along x-axis is given as x is equal to 20 plus t cube minus 12t. Or let me just rearrange it properly to write it as t cube minus 12t plus 20. That's how the displacement is changing. Let's try to solve A part, B and then C. In A, question wants us to find out the position and velocity of the body at t equal to 0. So let's put t equal to 0 here. So x will come out to be 0 minus 0 plus 20, or simply x is equal to 20 meter is the answer of first part. From here, if I want the velocity, I'll just simply differentiate the equation. So if you differentiate this equation, let's see this equation. In fact, यहाँ पे कर देता हूँ. So v is going to be ds by dt. That looks like 3t square minus 12, and rest of the part will become 0. So at t equal to 0, the velocity will come out to be 3 into 0 minus 12, or you can say velocity comes out to be minus 12 meters per second. That's basically the negative velocity, or direction of the velocity is negative. Okay, negative velocity means direction is negative. Next part, state whether the motion is uniformly accelerated or not. So let's find out acceleration, which is basically dv by dt only. तो इस इक्वेशन को डिफरेंशिएट कर देंगे हम लोग. वेलोसिटी का जो इक्वेशन है, that will come out to be 3t squares differentiation will give me 6t and 12 will become 0. That simply says that acceleration is proportional to time, which is not a constant again. So it is non-uniformly accelerated motion, guys. Okay, very good. Keep it up, guys, keep it up. C part, find position of the particle when velocity of the particle is 0. So let's make velocity of the particle 0. So v, which is 3t square minus 12, this is the equation of velocity. अगर velocity को 0 होना है, so let's make it 0, equate it to 0. So that is only going to happen when 3t square will be equal to 12, and you can see from here t square will be 4 and t will be equal to plus minus 2, but time cannot be negative. So the time at which body's velocity becomes 0 is t equal to 2. So from here, the position of the particle, let's put the value of t as 2, will be 2 cube minus 12 into 2 plus 20. So that is 8 minus 24 plus 20, which is 28 minus 24, that is 4 meter. Okay guys, that is nice, awesome. Sanjay Jadhav, the crash course that you are talking about is the crash course for all the 3 subjects. Okay, Sanjay Jadhav, the crash course fees which you see there in the description is the fees for entire crash course. Not just for physics, it's for physics, chemistry, maths and everything. Sanjay, I'm responding to your query. Okay, cool guys. Okay, now this one. The displacement of the particle is given by this equation. Sanjay, I answered your question. Okay, x is equal to a plus bt plus ct square minus dt to the power 4. The initial velocity and acceleration are respectively going to be what? So if you have your displacement given as a plus bt plus ct square minus dt to the power 4, the velocity is going to be dx by dt, which is differentiation of a is 0, this is b, this is 2ct and 4dt cube. So they are asking about the initial velocity and acceleration. Initial means at t equal to 0. So put t equal to 0. You can see that this will become 0, this will become 0, because of t being there. The only part which will not become 0 is b. So v will be equal to b. So either answer is going to be a or b, because c and d cannot be the answer, and acceleration is going to be dv by dt. So let's differentiate this equation. So that is 0 plus 2c minus 12 dt square. And here again, when I put t equal to 0, acceleration comes out to be 2c. This is what I get. Velocity as b, acceleration as 2c. So the correct answer is option B. Very nice, very nice. Gunadeep, Ashutosh, Tanuja, Jibika, Siddharth, Sakshi, Ashutosh, everybody got this right. Very well, guys. Keep it up, keep it up. Let's go quickly to the next question. Next question says that a particle moves along the straight line. Its position at any instant is given by this equation. Okay, x is in meter, t is in seconds. We have to find the acceleration of the particle at the instant when particle is at rest. So when the particle is at rest, this is basically when its velocity has to become 0. That is when you say that particle is at rest. So for that, I will obviously require the equation of velocity. So इसे differentiate कर दो. So that comes out to be 32 minus 8 into 3t square by 3. 3 and 3 get cancelled. What do I have here is to be equated to 0. That is the instant when velocity will become 0. So I can say that 8t square is equal to 32. T square will be equal to 4 and t can only be equal to 2 seconds. I hope you guys are not getting confused that sir why t is not equal to minus 2 seconds. Because t square equal to 4 means t equal to plus minus 2. But this is right and this is not right, or rather this is possible and this is not possible. Time cannot be negative. That's all is the thought here. So mathematically it is possible for a quadratic equation to have two roots, but practicality is basically told by physics whether it is really possible or not. Okay. Now, question is asking us to calculate the value of displacement at t equal to 2 seconds. तो x में हम वो वैल्यू पुट कर देंगे. So this is 32 into 2 minus 8 by 3 into 2 square. So x will be equal to, find the acceleration. My mistake, guys. We have to find out the value of acceleration, not position. So let's differentiate further, और फिर वहाँ पे we'll put the value of t as 2 seconds. So acceleration is going to be differentiation of this thing. इसका differentiation करना है. So this comes out to be minus 16t. And let's put t equal to 2. The value comes out to be minus 32 meter per second square. So it is either negative acceleration or it is retardation. Okay. Perfect. Yes, Jayashri, you are right. Time cannot be negative. Very good, guys. Tony Stark comes in my lecture. I'm so privileged. I'm so honored that Tony Stark is in my lecture. Okay, guys. Let's go to the next one, everyone. So the velocity of a particle moving along x-axis is given by this equation. And at t equal to 0, the body is at origin. That means x is equal to 0. So we have to find out acceleration at t equal to 2 seconds and x coordinate at t equal to 3 seconds. I hope you guys remember. If velocity is given as a function of time, then dv by dt will give me acceleration, and integration of v dt means differentiation will give me acceleration and integration will give me displacement. So I'm going to solve the first part. For that, acceleration is going to be dv by dt. So इसे differentiate करेंगे. This is 0 plus 5 minus 2t, and t equal to 2 seconds will be putting up there. So 5 minus 2 into 2. So the value comes out to be 1 meter per second square. That's basically the answer of the first one. The answer of acceleration is 1 meter per second square. I hope you guys are getting it. Okay. And the second one. What about the second one, guys? What's the answer that you guys are getting? Integrate करना है. Very nice. So displacement is going to be integration of v dt, and the time is going to change from 0 to 3 seconds. Okay guys, and from here velocity is 10 plus 5t minus t square into dt. This is going from 0 to 3. This is your equation of velocity. Okay guys, so integrate karte hain. This is going to be 10t plus 5t square by 2 minus t cube by 3 goes from 0 to 3. So let's try to put it here only. Only the upper limit will make any sense. 0 I will not even show, because when you put 0, any of these t values will become 0. So 10 into 3 minus 5 by 2 into 3 square minus 3 cube by 3. So that is basically 30 minus 5 by 2, and 3 3s are 9, so 9 5s are 45 by 2 minus, sorry, this is plus sign here. It's a plus sign here. Okay guys, thank you Sai. So if you simplify this guys, I will get 60 plus 45 minus 18 by 2. So that gives you what? 105 minus 18. 105 में से अगर 15 भी जाता है, so you will have 90, and 93 furthermore will go. So you will have 87 by 2. Okay, that's what is the answer that we are getting here. Okay guys, 89 by 2 or 87 by 2 is what we are getting here. 105 subtraction of this will be 90, 90 minus, so 87 by 2 guys, 87 by 2 it is, yeah, not 89 by 2. Cool, very nice guys, that's the correct answer. Keep it up. Thank you Parth, thank you so much. Next one guys, next one. A body moving along x-axis has at any instant its x coordinate to be x is equal to a plus bt plus ct cube. So what is the acceleration of the particle? Okay guys, okay, thank you so much for enjoying my sessions and liking my spoken, my way of speaking, and probably the way I teach. Thank you so much. Okay, so here again displacement variation is given and we have to find out the acceleration, so double differentiation. Okay, so from here let's find out velocity, which is dx by dt. So differentiation of a, b, c are constant, by the way. If not given, you will always assume a, b, c and anything like that to be a constant. So differentiation of a is 0, this is b, and 3ct square. From here, if I want acceleration, that will be dv by dt. So for that, 0 plus 0 plus 6ct. So acceleration comes out to be 6ct. Do I have the answers already? Very nice, very nice. Menti quiz is tomorrow, yaar. Tomorrow I am conducting Menti quiz. Okay? Very nice, everyone. Siddharth, Surendra, Vyas, Asmit, Jayashri, Sai Yuva, A to Z Technology, Ayush, Sagar, Asmit, Arnav, Ayush, Vinod, Ishwar. Very good guys, very good. Keep it up. Keep it up. Okay? Chalo, आगे जाते हैं. Next one. So here, what you see that the displacement of a body at any time t after starting is given by this equation. So we have to find the time when the velocity of the body will be 7 meters per second. So let's differentiate. So velocity is going to become 15 minus 0.8 t, and this value should be equal to 7. So that means 0.8 t will be 15 minus 7, which is 0.8 t equal to 8, or t will be equal to 8 by 0.8, or you can simply see that the answer is 10 seconds. So 10 सेकंड के बाद में जो velocity है, that will become 7 meters per second. Okay, great. What is 6ct? 6ct is acceleration. You differentiate t square. So t square ka differentiation will be 2t. Multiply this, you're going to get 60. Okay. Menti will be conducted tomorrow. In 12th standard, at 8 o'clock, there is a Menti for 12th standard. But for you guys, Menti will be tomorrow. Okay. We meet for MCQs on day 2 now. That is Tuesday. Okay, Denise. Welcome. Quick guys, next question. A particle moves along a straight line such that its displacement at any time is given by this equation. We have to find the velocity when the acceleration becomes 0. So velocity looks like is going to be 3t square minus 12t plus 3. Okay. And acceleration is going to be 6t minus 12. And this should be equal to 0. That means t will be equal to 2 seconds from here. So let's put that value here. That's what question wants you to find out. So that is 3 into 2 square minus 12 into 2 plus 3. So that is going to be 3 into 4 minus 24 plus 3, or 12 minus 24 plus 3. I hope I'm doing it right. That is 15 minus 24. That comes out to be minus 9 meter per second. Have you got the answer, guys? Yes, Ashutosh, very well. Siddharth, keep it up, guys. Keep it up. Very well. Okay, Chaiti Shiv Prasad. Good to know that you are in 7th standard. I hope you are not getting disheartened at the moment, because you are too young actually to know all these things. But it's okay if you are enjoying it. That's nice. So, guys, now a different type of question. The acceleration of the particle is given here, and the particle starts out with a velocity of 2 meters per second at t equal to 0. We have to find out the velocity at the end of 2 seconds. You know that change in velocity, which is v minus v initial, is going to be integral of a dt. And time is going to change from t equal to 0 to t equal to 2. And this value is given to us as 2 meters per second. So v minus 2 is equal to integral of 3t square plus 2t plus 2. Okay. Yes, we are covering both JEE Mains and Advanced. The topics are same. So this is v minus 2 equal to 3t cubed by 3 plus 2t square by 2 plus 2t. So 3 cancel, 2 cancel, and 0 to 2. So let's put the value of 2 here. So that will be 2 cube, that is 8, 2 square, that is 4, 2 into 2, that is 4. So this value is 16. So if you have v minus 2 as 16, v will come out to be 18 meter per second. Have you guys got the answer? It is live, Ishwar. Yes, Yuva, we are covering both mains and advanced. Okay, Denise, thank you. 8 o'clock, Sasikala, tomorrow 8 o'clock, Menti quiz will be done. Okay, cool guys. Next one. So if you have this one, this question says that if you have velocity given as s square plus s, then we have to find out the acceleration when the displacement is 1 meter. No mentioning of time. That means we will find out the value of acceleration as v dv by ds. So from here, let's find out dv by ds. So dv by ds is going to be 2s plus 1. Okay guys. So what is v? V is s square plus s. What is dv by ds? It is 2s plus 1. No need to cross multiply these two brackets, because we just have to find out acceleration at s equal to 1 meters. So put the value of s as 1. Okay. So what I'm getting here is 2 into 3. That value is 6 meter per second square. Are you guys getting it? Anyone got the answer? Answer is 6 meters per second square. Got it? Why? Because your acceleration, which is actually dv by dt, I told you people, we did this. We applied chain rule. this is how I wrote my acceleration, and this ds by dt is v. So whenever your velocity is given as a function of displacement, you can find acceleration in this form. Okay. Why cross multiply? There is no cross multiplication here. No matrix, no determinants. Okay guys. So need not multiply these because we already know the value of s. You can multiply, increase one step, then put the value of s as 1. Answer will come out to be same. Okay. Okay guys, this one. The acceleration of a particle along x-axis varies with position as a equal to 9x. Velocity is 0 at t equal to 0 and x is 2 meter. We have to find the speed at x equal to 4 and consider all measurement to be done in SI units. So guys, again acceleration is v dv by dx, that is given as 9x. So v dv, we basically need the speed. Okay, so we need the equation of velocity. So this is 9x dx. Now you will integrate this. So this comes out to be v square by 2. This comes out to be 9x square by 2. You can see that 2 and 2 cancels. So I have v is equal to 3x. Okay guys. So we have to, okay, just a minute guys. Limits are already given. Okay. So people here 0 to v and x is changing from 2 to 4. So I have v square equal to 9 into 4 square minus 2 square. Okay. So v square will be equal to 9 into 16 minus 4. That is basically 9 into 12, or you can say it is 9 into 4 into 3 as v square. So v comes out to be 3 into 2 into root 3. That means velocity is 6 root 3 meters per second. That's what we get as our answer. Okay guys. Cool. So because we knew the value of displacement at t equal to 0 and we needed the speed at x equal to 4, so limits of x changed from 2 to 4. Velocity was initially 0, then became v. Okay, no problem. Okay guys, now a JEE question for all of you guys. See, this is the question from JEE 2006. So velocity is changing as alpha root x. So v is alpha is a constant, x to the power half, and question is asking us to find out the displacement of the particle, how it is varying with time. So guys, what I'm going to do, I'm going to find out the value of dv by dx. Okay, so alpha remains there and differentiation is going to be half x to the power minus half, or you can say it is alpha by 2 root x. That's what is dv by dx. So the acceleration, which is v dv by dx, will come out to be alpha root x into alpha upon 2 root x. So you can see that root x and root x cancel. It comes out to be alpha square by 2. So acceleration is coming out to be alpha square by 2. And acceleration is something that you can write as dv by dt. So now I'm going to use this dv by dt as alpha square by 2 and I'm going to integrate this. So creating the space, we have alpha, that is dv by dt as, sorry, we have a acceleration dv by dt as alpha square by 2. So dv by dt is going to be alpha square by 2 dt, and you will integrate this to get v equal to alpha square by 2 into t. So here I have velocity ka equation as a function of time, and v I can write as ds by dt, which is equal to alpha square by 2 into t. Okay, so now what? ds becomes alpha square by 2 into t dt, and I'm going to integrate this now. So this is s, which is equal to alpha square by 2 into t square by 2. So that simply says that displacement is proportional to t square. Okay. Also, you can think of it in this way, that if your acceleration came out to be alpha square by 2, that is basically a constant. And for acceleration to be constant, displacement should be proportional to t square. That is only possible when the displacement is proportional to t square. Okay. T to the power 2. Okay. Yes, Ruchi, welcome. So guys, homework question for all of you now. A lot of questions we did, more than 10 questions we solved today itself. So the relation between displacement and time is given here. Okay. T equal to ax square plus bx, where a and b are constant. You have to find out the acceleration. This is JEE 2005 question as your homework. These are your options. Obviously, I want you people to tell me the answer in the comment box, and I will verify what is the correct answer. Okay, guys? Cool. Awesome. So, guys, if you are interested in covering the topics which are done before this lecture, अगर इससे पहले के sessions आपने miss किए हैं, so how can you, see all those lectures? This is how you can. Okay, all you have to do is go on the playlist of the channel, and on the playlist look for this playlist, JEE 2022. This is where you will find my lectures on units and dimensions, and after that lectures also, everything units and dimensions, or calculus, vectors, and kinematics is also being done over there. Okay, guys. Also, if you are interested, you can come to our Telegram channel as well. Wahan pe we discuss a lot of assignments. Assignment solution is what I provide there. Notes and daily updates are given. Again, if you want, all you have to do is go in the description of this video and you will find everything over there. Okay. So guys, I hope you enjoyed it. I have another session at 8 o'clock, 12 standard Menti quiz. So if you guys enjoyed my session, if you guys enjoyed this, then do hit that like button. Share with your friends. और अगर अभी तक नहीं किया है तो right now subscribe and press the bell icon. Okay, guys. Okay, Pratham, I hope you have subscribed. Okay, Shashi, Pratham, Nitin, Sakshi. See you all tomorrow with the Menti quiz. Okay. Something happening. Okay. Tomorrow, Menti at 8 p.m. for all of you guys. Cool. See you all then. Bye bye. Take care, guys. Take care. Bye bye.